There you go. So welcome back, ladies and gentlemen. We've had some tech issues. We're going to now continue on with our adding subtracting lesson on rational expressions. Example 3. And I'm only going to do 3 examples, question A, B, and C. And as you can see on the chalkboard, or if you're watching us live at home, not live, watching us from home, question 3A is m over 2m minus 4 minus 3 over 3m minus 6 plus 1. So this question is a little bit tricky. We're still going to follow the rules that we talked about in the previous YouTube video. We're still going to factor first, state restrictions, and simplify. And again, the idea of this adding subtracting, we have to make sure we have equivalent denominators. Finding that out is like finding the lowest common multiple. Add and subtract the numerators, and then sometimes use simplification further if necessary. So I'll do this first one. Factor everything. Let's do it. We get m over 2 times m minus 2 minus 3 over 3 times m minus 2 plus 1. Any questions from the class? Everyone okay? Does that make sense? Hopefully you tried it yourself in the class as I was dealing with the tech issues. Restrictions are really easy. M not equal to 2. And it's because of this one and this one. You don't have to write it twice, right? I think everyone agrees. Here is a hard question. What's the lowest common multiple? Now, I know there's a 1 there, so some people are getting nervous about this, and that's okay. This one is actually not that bad. So it is a fraction, right? It is a fraction. It's 1 over 1. But that's not really helpful. So, from someone from the class, can someone maybe try to tell me what do you think the lowest common multiple, now that you can see it? And again, it's kind of thinking of again what's missing. Michaela, you want to try?
Is it 6 times m minus 2?
Beautifully said. That is the correct answer. Notice one more time, ladies and gentlemen, it's not just the product of the two. It's not 3 minus 2 times 2m minus 2. It's not always going to be those two denominators. And that's why, again, the way that I said it, when we look at these two denominators, this is 2 times m minus 2. This is 3 times m minus 2. Okay, wait a second. They both have m minus 2. This is only missing a 3. This is only missing a 2. And then when you multiply those out, that's why you get 6 times m minus 2. Which really means this is only the first part. But this example, for some reason, is also devious because I need to make this one the same denominator of 6 times m minus 2. So you know what this is going to be? We're going to take that 1 and multiply by 6 times m minus 2 and 6 times m minus 2. Let's just pause and let that sink in. And again, what I'm writing here beside, ladies and gentlemen, most students actually, when they do their work, they don't tend to do it. They tend to write it out, maybe on a scrap piece of paper or anything like that. Any questions in that class before we keep on going? So let's just go a little slower, and let's put it all together. Three times m, that's 3m. Notice I'm nervous about the subtraction, and that's why we're trying to train you. So I'm just going to subtract it. I make that yellow, but it's just to make sure everyone's okay. Now in this case, this is actually not a big deal. 3 times 2 is 6. This is the plus sign. And what is this? 1 times 6 times m minus 2? 6 times m minus 2. Before we continue, everyone okay? Any questions from the class? And again, if you can't see it because of the stand, I do apologize. Just stand up. We're asking you to, make it larger. Because you, the class students, you're the most important. Not saying you're at home, ladies and gentlemen, watching this, aren't. I don't know. So let's just finish this off. Again, I'm running out of room. And the reason why I do not expand the denominator is because sometimes, again, a lot of you realize sometimes we have to divide out. This is bad math. 3m plus 6m is 9m minus 18 over 6 times m minus 2. Anyone see anything suspicious? Anybody? Anyone see anything interesting with that 9m minus 18? Michaela again!
You can factor the numerator to be 9 times m minus 2.
Nice! So I apologize. have to move this over. So we get 9 times n minus 2 over 6 times n minus 2. Notice Miguel was going, hey! Again, we didn't know that when we did this. It's almost impossible to see it. We didn't realize. Anything we can do to simplify further? Anybody from the class? Now that Michaela's done the hard part. Anyone see anything interesting? This 9 times n minus 2 over 6 times n minus 2? Or Shia?
We can cross the n negative n minus 2.
For sure. What else can we do?
6 and 9. Both of them can divide by 3.
Nice! So 3 goes into 9 3 times, and 3 goes into 6 2 times. And ladies and gentlemen, the final answer for this question, I kid you not, is 3 over 2. Crowd goes wild. And that is why, one more time, ladies and gentlemen, I showed you in the previous example, in the previous video, example 2, sometimes, not always, sometimes we simplify further. Any questions from the class? And anyone from home, please feel free to email me if you're not too sure. This question was actually neat. A lot of moving parts going in this example. I don't normally go this fast. So don't feel bad if you're alarmed. Couple things to revisit again. There's 3 questions that we have to add or subtract. Gotta get a lowest common multiple. That was the kind of tricky part. We also have this number 1, right? All things to think about. I think everyone now understands this. We didn't have a problem with the subtraction. When we simplify, we got this, wait a second, 9m over 18 divided by 6 times n minus 2. That's why I didn't expand this, because it's sometimes easier than to realize we get this. And this doesn't always happen. This yellow rule does not always happen. And then notice what happened. Hey, not only can we reduce the coefficients, we could also divide out the m minus 2's in this case. Question from the class, last chance. Not last chance, but anything that might help the people at home that are excited to learn math. None of you are. Right, let's get to question B then. Oops. 3. So we have x over 6x plus 6 plus 5 times 4x minus 12. I think I did that right. Hopefully I copied the question right. Yep, I think I did. The restrictions are x can equal to -1 or 3. And some of you are realizing with adding and subtracting, the restrictions tend to actually be very easy. Right? So the restrictions, I don't think they're very arduous. Like, no, they're not like our multiplying and dividing questions. Right? They tend to be pretty easy. The question difficulty, I think of this as the whole gamut of lowest common multiples and adding, subtracting, and being careful and simplifying further. That's actually this part, right? I think everyone agrees. This part, it's just a formality, but it's a common mistake that some students do forget. They just start firing through that. So they factor first and they did this, right? So what's the lowest common multiple in this case? Do you have anyone try? Sure.
Is it 12x?
It is not 12x, but you're really close with the coefficient. You're for sure correct with the 12. Everyone agree? This 6 and this 4, the lowest common multiple between 6 and 4 is 12. Nicely done. But it's not 12x. Danny, would like to help him out a bit further?
Will it be 12 times x plus 1 times x minus 3?
Nicely done. In this case, again, it's not the true product of the two, but this fraction is missing that x minus 3. X minus 3, and probably a 2, because we want to get the 12. And this one is missing the x plus 1 over x plus 1, and that's 3. So what the lowest common multiple was for this question, I called it, it is 12 times x plus 1, that's a 12 there. Let's see that? So it's almost always products. So now let's keep on going with this question. Notice again, I don't expand that. I don't. we rarely actually expand the denominator. So trying to leaving it in the factor form is the best suggestion. And let's go slowly. 2 times x times x minus 3 plus 5 times 3 times x plus 5. I'm just gonna go this slowly, just to show you what you're doing. Again, some students don't, they just start executing. So some students actually do 2x. I'm just trying to share with you what happened. 2 times x is 2x, and then distribute that. 2x times x is 2x squared. 2x times negative 3, that's negative 6x. Hopefully I'm not wrong. And again, I apologize, ladies and gentlemen, this mess on the chalkboard is from the caretaker that was trying to help me out, but made it worse. Plus sign is not a big deal, so 5 times 3 is 15. 15 times x, using the distribute part of 15x. 15 times 1 is plus 15. And let's just see if this is going on the camera. It is still. Then we have to collect the like terms. 2x squared, and I think 15 minus 6 is 9, is that right? 9x. Over that 12 times x plus 1 times x minus 3. And I think, let's just check, is that 2 and 1? Can we factor that further? 2 and 1, 5 and 3, 6 and 5, no. How about this way? 3 and 5, 10 and 3, no. How about 15 and 1, nope. 15 and 1, nope. So I don't think it's factorable. And even somebody might know what I'm doing here. I check with the discriminant. That's b, which is 9. So 9 squared minus 4 times 2 times 15. This is 81. This is a huge number. This is not factorable. I'm just trying to share with you. This is the whole problem with adding and subtracting of rational expressions, that when I do the sometimes we simplify further, this can't be simplified any further. So notice, sometimes, unlike our previous examples, and that's why in this example, we could factor, but sometimes if you got to this answer, and that's why I'm leaving question 3, example A, if you got this far, that's amazing. Don't get me wrong, you should applaud yourself that you got this far for this question. You just wouldn't get full marks. Like, let's say this question was out of 5 marks, you would have gotten 4 out of 5. Of course, with the restriction part, right? Hopefully. 4 out of 5. And this part is actually the extra stuff to get perfect. Whereas this one, notice we tend to have a standard form question, because normally that usually terminates. Any questions before we get to example C? Questions about example C? Is that on the chalkboard? I do have to erase this example A though. Example A is a great one, and don't feel bad if you have to look it over again and you do it again at home. If you have time, it's kind of neat. And whatever works for you, whatever, if you want to fully show your work for those solutions. So let's go quickly to example 3C. That will conclude this part of the lesson. And again, I'm not going to do question D if that's okay. I am not. Question C is as follows. 3 over x squared minus 2x minus 3 minus 7 over x. Any volunteer from the class now would like to try to help out Mr. Chen? Factor out this denominator. This is obviously the first step in blue. David, sure.
So it's 3 over x minus 3 times x plus 1.
Nicely done. Everyone okay with that in the class? Okay. Somebody new perhaps, if that's alright? Somebody new? Give us the restrictions. I'll lead you a little bit for the class. Somebody new, maybe? Maybe Eric or Holly. Tyler, sure.
Positive 3, negative 1, and 0.
Nicely done, thank you, Tyler. X cannot equal to 3, negative 1, and 0. Any questions still from the class? I don't need to be presumptuous again. I think a lot of you are saying it slowly, even if you're internalizing it differently. These are like zeros, right? X-intercepts or roots, if that's what you did in grade 10. And again, these values, my father said, if they were ever these questions would be divided by 0. what do you think is the lowest common multiple? Somebody from the class. If you get this wrong, who cares? Who cares? It's Thursday, almost the weekend. I'd rather be doing math and freezing outside. Anyone out there from the class? What do you think the lowest common multiple is? Sure, Daniel, if you don't mind.
It would be x times x minus 3 times x plus 1.
Beautifully said. So in this case, this question seriously was the product of the two. So I like doing this. Some students don't do this, some teachers don't even teach this. I think this just helps you focus what you need to do. In short, one more time, and again, I was using orange. I should have used orange. That's what I was using. So this fraction, whatever this is, here, whatever this is missing the x over x. And this fraction is missing that x minus 3 times x 1. X minus 3 1. Before we continue, okay, again, I like doing this because then it guides you what you're supposed to do. Where's my white chalk? Delay. So, what do we got? We got 3. Well, let's just do the denominator first. X times x minus 3, 1. Hope that was okay. That's the denominator. I think everybody agrees. That's a little. This is 3 times x. That's not a big deal. Right, so 3 times x, 3x. Minus, So watch what I'm doing, ladies and gentlemen. And this is why this question is hard. I do apologize. I need to erase question B off this chalkboard. Just to make some room for this question. And again, ladies and gentlemen, I know some students argue with Mr. Chen is, I have to write so many of these stuff. Like, why? It's just the nature of it, right? So go slow, go carefully. And it's also training to copy carefully, right? So what we have is 3x minus, and watch what I'm going to do. I'm actually going to multiply this out. So a lot of you already know what x minus 3 times x1 is. X minus 3 times x1 is x squared minus 2x minus 3. Exactly what Damien did. So technically, if you take this step here, this might make more sense. And some students don't even do this intermediate step. So I'm trying to show you. If you don't go carefully, you'll have a difficult time. So for this example, again, a good question that a lot of students have. Do I have to write all this? Again, most students go from this step to this step. But to explain it, this one is what's happening. That's why, one more time, you have to be careful with your understanding of subtraction. And then now you put it all together. Negative 7x squared plus 17x plus 21 over x times x minus 3. And I think I checked this as well. I don't think this is factorable. Let me just check really quickly. Please don't be factorable. I don't want to do it. I actually don't even know what 17 squared is. I should know, but I don't know. 289. It's 4 times negative 7. 21. Ay-yah. Come on. And if you don't know what this is, don't panic like that. I don't think this question. Oh my god. That's not right. 21 times 28. That's 588. Plus 289. Square root of this, I don't think it's a good. So it's not factorable. So that's the answer. Whew. Any questions from the class? Anyone still not too sure what I did? It's okay to ask. So the answer again one more time is negative 7x squared plus 17x plus 21 over x times x minus 3 times x plus 1. With those restrictions. X cannot equal to negative 3, sorry, not x cannot equal to 3, negative 1 and 0.